I'll record this part anyway. Yeah, I forgot to press the recording button here, but good that I saw it. So let us go to GeoGebra now. I want you to learn how to do it in GeoGebra as well. So let us just go to CAS view and let us get rid of the view that we don't need. So I take graphics view off. So in GeoGebra, for some strange reason, you don't have sigma notation, but instead of sigma, you have sum. So you just write type sum, and then you see that you go here and choose this one, sum, expression, variable, start value, end value. So I choose this one. Let us calculate the same sigma that I did here. So instead of expression, you type what is in front of your sigma, so it becomes 2k squared, and then plus 3k. And then here, the variable is what I call the counter. You have to mention what is your counter, and that is the name of it, which is k. And the start value in my case was -2, if you see that on the board, and the final value is 1. And then you press enter, so this answer is 6, as we derived it there. Okay, so this is the way that you use this using GeoGebra. So there is no sigma notation. Sigma notation is replaced by the word sum, which is actually what sigma means. Okay, but let me also ask you one more question that you can solve using GeoGebra. Do you remember we had some sum like that, if I remember it correctly? So if I ask you to use GeoGebra to calculate this sum, so how do you do that? This is, of course, something that you can do without using GeoGebra. If you go to my previous examples, if I remember correctly, I did exact example without GeoGebra, of course. But now that you have GeoGebra available, if it is available, you might be able to find it easier. But my point is to practice on the sigma notation, because when you have it in sigma form, then you can put it in GeoGebra. Okay? So how can I, my question is that I want to add up these numbers. So my goal is to write -5 plus 1 plus 7 plus, the next one is 13, and then you continue, at some point you reach to this one, okay? Can you put this in the sigma form? So what I'm asking you is to write a sigma. When I say to write a sigma, I mean choose a counter. So if you don't mind, let us choose the counter to be this. It means that you need to fill up these gaps for me. If you can fill up these gaps appropriately so that this sigma, when opened up, generates this list, then I can use this and put this in GeoGebra and find the answer. Yes?
You put 1 as I.
In front of I, not as I, because that is also I. Yes?
Okay.
Yes? So put I, you start from 1. Yes, up to?
And then in front of it, you write -5 plus 6n.
Plus?
6n.
6n.
Or,
so if you say n, then you have to choose this one to be n as well. Yes? It's 200, yes?
Yes.
Because you are correct. Because you see, if you put 1 instead of n, it becomes -5 plus 6, which is it correct? So did you say -5 plus 6n?
Mm-hmm.
No, but then this does not generate this one. Okay, you can start from 0, I don't know. So you can start from 0 if you want to, yes? Because then if you put 0, it gives you -5. Okay, so but my point is don't write -5 plus 6n, because you know that this is an arithmetic progression. You can find the formula for an. An is a1 plus a minus 1d. A1 is what? -5. D is 6 in this case. So 6 times n minus 1. So it becomes 6n Minus 6 minus 5 is minus 11. So I prefer to write it down as this one. That the one that you said is also good, but you have to start from 0. Yes? If you write what you wrote, but you start from 0, that's okay. Okay, and then what is the upper one? I want to see how much I need to continue. I need to ask myself for which n this generates this number, because that's the last one. Yes? So in other words, I want to have 6n minus 11 to be in this one. So you move this to the other side. Yes? It becomes what? 6, 0, 2006. Am I right? Yes. Is that, no, sorry, what I'm writing. It's this. And then n, what is that? If you divide this by 6, it becomes 201. So I know that this question mark is 200 yes? That's also one way to do it using GeoGebra. Now I can put this sum in GeoGebra, so let us just do that. So I would write sum. So what is my expression? The expression is 6 times n minus 11. What is the name of my variable is n. What is the lower limit is 1. What is the upper limit is 201. Yes? And then I press enter. I don't remember what we got last time, but might be you can check your answer in your notebook. So it is this number. Yes? So it is good because I saw this sigma notation in the book. Might be you don't know it from Math 1C. So I wanted to repeat that. Any questions here? Okay, so let us solve one more question here, and then we go to the next topic, which is actually a geometric progression. Okay, so let us go to the next example. So let me write this example here for you. The sum of 5 consecutive terms of an AP is equal to 10, and their product is 320. Determine this AP. Okay, what do I mean by determine? Determine means find the first term and d, because if I ask you to specify the arithmetic progression, it means that give me the first one and give me d, I can generate every term, yes? So when sometimes you see find a1 and d explicitly, sometimes they ask you determine this AP, it means that find a1 and d, yes?
How do you get the different answer?
You got?
But read it. Look at the board, you have wrote 1,195. But GeoGebra generated the number.
No, I am asking the sum. 11,000, so 1,195 is the last term. This is the number for if I add all those numbers in my list. Yes. I told you that because I remember, if I am right, this is exactly the example I did last time without GeoGebra. I want you to check this number, GeoGebra, with the one that you might have on your notebook. Okay, I want to wait for you a little bit so that you can think about this, then we switch gears and go to the next topic of these sequences. Okay, could you solve this? This is a little bit it's not a standard problem, because usually when I talk about the sum, you will go and try to use the formula for the sum. Okay, and first of all, that sum Sn means the sum of the first n terms, but these are just some 5 consecutive terms of an AP. This is not guaranteed that these 5 terms are from the beginning to the 5th term, yes? But we know that they are consecutive terms of an AP. So, if you want to think a little bit outside the box, it would be easier to understand what is the meaning of an arithmetic progression. So I have 5 numbers. They are consecutive terms of an arithmetic progression. I don't know anything about these numbers, and I don't know anything about the common difference, but I would say that let D be the common difference yes, and let X be the middle term. Middle number in this list. So let us try to talk a little bit about that. Why do you think I chose X to be the middle one? I could have chosen X to be the first term. If I choose X to be the first term, what will be the second term? The second term will be X plus D. The term after that will be X plus 2D. The term after that it becomes X plus 3D. And the term after that it becomes X plus 4D. Yes? If I choose D to be the common difference, and if I choose X to be the first number in my list, then you agree with me that the other numbers would be of this form. And if I want to add them up, it is not hard. I add them. It becomes X plus X plus X plus X plus X, D plus 2D plus 3D plus 4D. But I try to use a little bit of symmetry, because that is up to me to decide what is X and D. I prefer to put X to be the middle number. If I choose X to be the middle number, so it means that I have 2 other numbers on the left and 2 other numbers on the right. But can you tell me what will be the number before that? X minus D. And what will be the number before that? X minus 2D. And then what will be the number after that? X plus D and X plus 2D. Of course, technically speaking, you have freedom to choose this, but I hope that you agree with me this is better, because the algebra becomes simpler. Yes? If I start adding them up, instead of having also D added, these are cancelled, so I am left with just one unknown. So this is a little bit of technicality. I want you to have this experience. So I would say that, okay, then the numbers take the following form. Yes? X minus 2D, X minus D, X, X plus D, and X plus 2D. Okay? Is that understandable so far? Okay, now I use the other pieces of information given in the problem. I know that the sum of these 5 numbers is supposed to be 10. Yes? So it means that if you add these numbers, the answer is what? The answer is 10. Yes? But now, because of my choice, I would say wise choice, I don't need to be bothered about D. I can immediately find X, Y. Because of by symmetry, this 2D and that 2D are cancelled, this D and that D are cancelled. I am only left with one unknown, and that is X. X, 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 X 5 times, so 5X is equal to 10. So I realize what is the middle term. The middle term is nothing except 2. Yes? But it is not enough, because I am supposed to determine this AP. To determine the AP, I need the first term. I also need the common difference. Okay, so I need another piece of information which is also provided for me in this problem. And I know that the product of this list is supposed to be 320. But I already know x. So I know that the product of these numbers, x minus 2d, x minus d, x plus d, and x plus 2d is supposed to be what? 320. Yes? But now I already know what x is. So x is 2. So this means 2 minus 2d, 2 minus d, 2, 2 plus d, and 2 plus 2d is equal to 320. Yes? But you see that I can factor a 2 out here, which after being multiplied by 2 gives me a factor of 4. I can also a factor of 2 here, it gives me a factor of 8. So then I divide everything by 8. So the left-hand side becomes 1 minus d, 2 minus d, 2 plus d, and 1 plus d. On the right-hand side, I will have 40. Yes, is that right? So I factor the 2 out, and the other 2 is here. So 2 times 2 times 2 is 8. And then I divide this by 8, it becomes 40. I cancel the factor of 8 from the left-hand side. From this one, this is left. I copied and pasted this one, this one, and then from this one, this is left. Is that right? But this is also not that hard to understand. How do you multiply this? In principle, I have to multiply these 4 pair of brackets, but I can use the conjugate rule 2 times, yes? Because this one with the last one form a conjugate rule, and these two also form a conjugate rule. So this multiplied by that is the first one squared minus the second one squared, and this times that is the first one squared minus the second one squared, and the answer is 4. Okay? And at least this is a one equation in one unknown. I have to solve it. Okay? So how should I do that? I start multiplying. There's nothing I can do. 1 times 4 is 4. 1 times minus d squared minus 4d squared and plus d to the power of 4, and that's equal to 40. So I would write as d to the power of 4. This one minus that one is minus 5d squared. I move 40 to the left, it becomes minus 36 equals to 0. So then I have to say, yes?
Shouldn't it be minus 3 d squared? Go for negative.
Minus here,
Yeah.
minus d squared minus 4d squared is minus 5d squared.
Oh, minus.
Yes. But how can I solve this equation? Yes?
You substitute d squared for another
Variable. Exactly. This is in Math 1C Math 3C problems. You have seen that probably. So I would say let d squared be a new variable. Let us call it capital D. Then what happens to d4? D to the fourth becomes capital D squared. Okay? Then if I replace it here, it becomes d to the power of 2 minus 5d, minus 5d minus 36 equals to 0. And you can use ABC formula to solve that. So d becomes minus b plus or minus the square root of this power 2. 4 times that one is positive 144, and then divided by 2. So this becomes 169. The square root of 169, I have it in my memory, is 13, and then divided by 2. So I will get 2 answers for capital D. So one answer is 5 plus 13, 18 divided by 2, 9. And another answer is 5 minus 13 minus 8 divided by D divided by 2 minus 4. But the goal was not to find capital D. Capital D was something that I brought in to simplify my problem, but at the end, what I'm interested in is the little d. So capital D is d squared, so d squared is 9. It means that what is d? Plus or minus 3. Yes? But what do you think about this one now? Instead of capital D, I put little d squared equals to minus 4. What should I write? Yes?
D squared can be negative.
Yes. So no solutions. Okay, so I realize that there are two possibilities for my D, either positive 3 or negative 3, but I have to specify my sequence. Okay, so if D is positive 3, what is the first term? The first term in my list is x minus 2D. Yes? X is 2, D is 3, 2 minus 6 is minus 4. So the answer is either minus 4 and then minus 1 and then 2, etc. Or if D is minus 3, yeah, thank you. If D is minus 3, x is 2, so 2 minus 2 times minus 3 is 8. Yes? And then the next one is 5, the next one is 2, etc. So these are two options that I have. Yes? These are my arithmetic progressions. Either the first term is minus 4 and the common difference is positive 3. Did I make something? Yes. Or the first term is 8, but the common difference is negative 3. So these are the numbers. So that was a little bit hard problem. The reason is that you have to think a little bit outside the normal box of using just the formulas. Yes? Having a deeper understanding. Okay, so now let us go. Any questions here? No? Okay. So I hope that the next topic will be a little bit simpler because we want to talk about geometric progressions. So a geometric progression is the one that each term is obtained from the previous one. Instead of adding some constant number is to multiply it by a constant number. Then you generate a list of numbers. That list is called a geometric progression. So let us try to see what does it mean. So for example, I start from a number. To go to the next number, I multiply by a constant number. In your book, because of the Swedish word, they use letter K, but the English one is usually the standard word Q. So let me just write that. So instead of adding, so I multiply Q here. So let me write it like this. I multiply A1 by Q, I get A2. I multiply it again by the same Q, and I get A3. And if I want to go further, I multiply it by the same Q, I get A4, and then this list can go forever. So the difference is that in an arithmetic progression, I add a number all the time, but in a geometric progression, I multiply a number. For example, I can start from 1, and every time I multiply by 2, for example. Then what happens? This becomes 2, this becomes 4, this becomes 8, 16, 32, and etc. So that is a geometric progression. This number that I am multiplying all the time is called the common ratio. Okay? So Q is called the common ratio. In the previous case, it was D, and it was called the common difference. Okay, do you remember in the arithmetic progression, D could be in principle any number, but one number is more or less not very interesting to us. What was that number? Everyone? 0. Because if that's 0, you generate the same number. So here, there are 3 numbers that usually we don't like them, because this gives rise to something trivial. So one of them is 0. Because if it is 0, the first term is whatever it is, the rest of the terms will be all 0. Yeah? And there's another number. So usually, not usually, we say that Q is probably not 0. On the other number, which is not very interesting here in this case, what it is? 1. Because it will generate the same number all over again. And there's also another number, probably is not that interesting. -1, because it gives you the same number with different signs alternatingly, yes? So usually, it's not, of course, forbidden, but this is something that we don't like to have because it gives something trivial and we don't need to do that. Okay, for example, do you think that this is an arithmetic progression? Sorry, geometric progression? Yes, do you see that this is also a geometric progression? So what is the common ratio here?
Square root.
The square root of 2. I multiply this by square root of 2, it gives me this one. I multiply this by the same square root of 2, it gives me this one. I multiply this by the same square root of 2, gives me this one, etc. Okay, in the arithmetic progression, we had two formulas. One formula for a number n and one formula for Sn. You want to have the same formulas here. So I want to have an and I want to have Sn for the geometric progression. So I will use GP for geometric progression. So let me write GP here. Okay, can you answer this one? Yes?
A to the power of n minus 1.
Yes, why? Because you see, if I want A2, I multiply A1 by 1 cube. But if I want A3, I multiply A1 by 1 cube, it takes me to A2. Then I multiply by another cube, it takes me to A3. So in order to reach to A3 from A1, how many multiplications by Q I need? 2. If I want to go to A4, how many multiplications by Q I need? 3. So if I want to go to AN, how many multiplications by Q I need? N minus 1. Okay? So this becomes A1 Q to the power of N minus 1. But for Sn, the problem is a little bit harder. Okay, so if I want to find Sn, Sn again means the same thing. It means the sum of the first n terms. This is the meaning of Sn, exactly as before. But of course, the formula shouldn't be expected to be as the same as before because this is a completely different topic. So, do you remember how we got Sn for arithmetic progression? So we use this Gauss method, yes? We write it in the reversed order and add them column-wise, yes? But that idea will not work here. I hope that you agree with me. Yes, because for example, let us take this and write it the other way around. 8, 4, 2, 1. But when I add them, yes, this becomes 33, but this becomes 18. This becomes what? 12. This becomes 12. So they repeat themselves, but they are not all equal. In the case of arithmetic progression, when I did that, when I added column-wise, all the numbers are the same, so I could use multiplication. But do you have any idea what to do here? So let us, for example, concentrate here to understand the problem. So let us say that I want to calculate this. Of course, this problem is super simple. I don't need any formula. I can just add them in my head, yes? But let us pretend that we cannot do that. I want you to discover an idea. If I ask you what is the sum, you can add this up, of course. But I want you to do it in a way that you can take the same idea that you discover so that you can generalize it to even 100 terms, 1,000 terms, yes? So do you see that what we can do? The idea is to multiply both by the common ratio. Of course, in this case, again, in this case, it is 2. So I multiply everything by 2, okay? So what happens? This becomes 2, this becomes 4, this becomes 8, this becomes 16, this becomes 32, and then 64. Okay, do you see what I am going to do now? I want to find S. What do you think I will do? So many of the numbers are in common. So if I subtract them, many things will gone. Yes? So what I do, for example, let us take S minus 2S. Okay, but then if I multiply this minus sign, minus 2 and 2 will be gone, minus 4 and 4 will be gone, minus 8 and 8 will be gone, minus 16 and 16 will be gone, and minus 32 and 32 will be gone. Yes? So what is left is 1 minus 64. Yes? And then s minus 2s is minus s, this is minus 63, and s is 63. Yes? So I was able to add this number is 63. Let us add 1, 3, 7, 15, 31, 63. That's correct. So that is the idea. So if you want to find the sum of a geometric progression, take your sum and multiply it by the common ratio of that geometric progression. You will have a lot of terms in common, and you subtract them, most of the terms will be gone. And there are only 2 terms left. The first one of my first list, the last one of my last list. And then I subtract 2 numbers. So instead of adding 1,000 numbers, for example, I just subtract 2 numbers. Is that right? So we can have this idea in general. So let us just do the same idea, but I want to do it in a way that I can reach to a formula and write it down and use it for the future reference, okay? Okay, so let us just do it together. So here, I am interested to calculating Sn. Sn, as I told you, is A1 plus A2 plus A3 up to, say, an minus 1 and the final one an. So can you tell me what should I do according to what I told you? So here, how many numbers I have to add? I have to add n numbers. But if I multiply by what? In general. There I multiplied by 2 because the common ratio was 2. Here I should multiply by q. So it becomes, so if you don't mind, let me multiply by minus q, because it is easier for our brain to do it in that way. So what happens? It becomes minus a1q minus a2q. I'm multiplying this list by minus q because I want adding is easier for us than subtracting. And then minus a3q minus this one becomes minus a n minus 1q. And finally this one becomes minus a n q. Yes? Let me now ask your opinion. So this means that this, what can I write instead of this?
Minus A2.
Minus a2, yes? Forget about the minus sign. If I multiply a1 by q, according to the definition of the geometric progression, this becomes term number 2. But I have a minus sign, so it becomes minus term number 2. For the same reason, this becomes minus term number 3, yes? This becomes minus term number 4, and then if I continue this process, can you tell me what happens here?
Minus A.
Minus a term number n, but for this one, it becomes a n plus 1. Let us keep it like this. So I make an exception. I keep it exactly as this. Now you see that if I take this one and that one and add them up, Sn plus minus Qsn becomes equal to minus a2 and that a2 are gone, minus a3 and that a3 are gone. Minus a4 is also cancelled. Why? Because a4 is coming next, so this will be cancelled as well with the next one. And if I continue this list, an minus 1 is also cancelled from the previous one, and this one will cancel that one. So again, as before, 2 terms survive. The first one from the first list, the last one from the second list. So if I add them up, it becomes a1 minus an q. Yes? But I am looking for Sn. So in that case, it was 1s minus 2s, so I wrote minus s. But in this case, because q is in general a given, I don't know, so I factor it out. I factored Sn out. And then on the right-hand side, I have a1 minus an q. Yes? I am looking for Sn. I have to isolate Sn. So I have to get rid of this factor. I do it by dividing everything by 1 minus q. So this becomes Sn. This becomes a1 minus an q divided by 1 minus a. But when I divide in mathematics, I have to be careful that I am not dividing by 0. So this method only works if q is not equal to 1. Because if q is equal to 1, then I have problems here. But is q1 a big problem? No, because if q is 1, what does it mean? It means all the terms are equal. And if I ask you find the sum of equal numbers, you just multiply that number by the number of repetitions. So the hard one is the one that q is not 1. If q is 1, we really don't need to go through this torture, yes? We just multiply that number by the number of repetitions. So that's not a big obstacle. So, but I just want to tell you that this formula is valid only if q is not equal to 1. Okay, but this is not the formula that you have in the book. Well, let us manipulate it a little bit so that it becomes familiar. There is a weakness in this formula. What is that weakness? I want you to understand, especially in physics, this is important. When you read the question in physics and then you want to write the answer, the formula that you write should depend only on the given information. Yes? So do you see that this is not the case? When I give you an arithmetic progression, what do I usually give you? I give you the first term and I give you the q. And when I ask you to find the sum, I expect you to write a formula that depends only on the first term and q. But this formula depends on the first term, depends on q, but also depends on something that I, in principle, don't give you, okay? So this means that you have to get rid of an. But that's not a big problem because we already know what is an. What is an? It's a1 q to the power of n minus 1. So I take this one and put it here. So this becomes a1 minus a1 to the q to the power of n minus 1. But there is another q that I multiply here. This is 1 minus q. Is this formula acceptable? Yes, because it depends only on a1 and q. But the problem, what is the problem with the formula? The problem is that it is not beautiful. So you have to polish it, yes? That's also a problem, yes? Ugliness is a problem, isn't it? So a1 minus a1 q to the power of n minus 1 times q is to the power of n. And then 1 minus q. I also prefer to factor a1 out, so it becomes a1 1 minus q to power n divided by 1 minus q. So let me write this exactly here. So for a geometric progression with term number 1 a1 and the common ratio q, of course if q is not equal to 1, then this is Sn. Yes, and q is not equal to 1. I don't remember your book written it in this way because some books write it in that way. Some books prefer to multiply the numerator and the denominator by 1. So if I by minus 1. So some books write this one the other way around. So if it doesn't matter which one you see, both of them are correct. So if you decide to bring 1 first, you have to bring 1 first here as well. If you decide to bring q first, you have to bring q first as well. So it doesn't matter which one you use. So these are two formulas that are counterparts of the formulas of an and Sn in the arithmetic progression, but in the geometric progression. Is that clear? Yes? Okay. So let us solve some problems. So more or less everything is finished. You need to know a little bit of problems to improve your skills. So example, in a geometric progression, in a GP, the sixth term is 53, and the eighth term, how do you write eighth? Something like that, yes. Is that right? eighth term, do you write the eighth like this? Yes, okay. So eighth term, it doesn't look familiar to my eyes anyway. So, and the eighth term is 477. Determine the tenth term. Okay, so this is a very simple question. So how should we do that? Let us read the information. I have a GP, a geometric progression. The sixth term is 53. So it means term number 6 is 53. And term number 8 is 477. I want to determine term number 10. So let me write, A number 10 is needed. So what do? I think you understand that we have to use this formula. There's nothing about the sum here. So I use this standard formula. So instead of A6, what can I write? For A6, I can always write A number 1, Q to which power? 1 unit less, 5, is 53. So of course there are two unknowns. So there are infinitely many choices if I consider one equation with two unknowns here. But there is another piece of information. Number 8 is A1 Q to which power? 7. Okay, so the only problem is that I want to tell you how to solve this system. In principle, you have two equations and again two unknowns. One of the unknowns is A1, the other one is Q. So how do you think I will solve this problem? To find A1 and Q? Because this is a system to consider, yes? In the case of in the case of arithmetic progression, the system was very similar to the systems that you learned in Math 2C. But here the system is very simple, even simpler than that one, but it is not that standard as you have seen. But the standard way of solving any system is method of substitution. Yes, you have to get rid of one variable at a time, so that you can have one equation in one unknown. This is the general strategy to tackle any kind of systems, yes? So how can I get rid of one variable here?
You divide.
Divide. So if you know what the goal is, it is not that hard to come to your mind. Because I want to get rid of one variable and be left with one single variable so that I can solve. And I hope you see that is not hard. If it was hard for you, remember this trick for this geometric progression. So you start dividing. And if you don't mind, let me divide this one by that one, which I have bigger numbers divided by the smaller numbers. So I write A1, Q to the power of 7, and this is 477. I divide these, the sides of this equation by the sides of that equation correspondingly. So this becomes A1 Q to the power of 5, and then it becomes 53. So everyone understands that this is logical? Yes? Okay, and now what happens, you see your goal is reached, yes? Because A1 is gone. And 1 is left, which is Q. So this means that this becomes Q to which power? 2. And then, is that a nice number? 9, yes, it is 9. So Q squared is 9, and then what happens? Q becomes plus or minus 3. Both of them are acceptable. Okay, but I want to answer A10. What do I need to answer A10? I need A1 times Q to which power? 9. So I need both of them. For Q part, I don't have any problems. I found it. So I also need my A1. But that is a simple problem, yes? Because when I know Q, I put it back either here or there, then I can find A1. I would prefer this one because that is dealing with the smaller numbers. So here, so let me write equation number 1. So if I put this in equation number 1, what happens? So this becomes A1, which I don't know. Q, either plus or minus to the power of 5 is equal to 53. So this number to power 5 is 243, positive or negative, because this is odd. If it is positive, it remains positive. If it is odd, it remains, if it is negative, it remains negative. So this becomes plus or minus 243, A1 is equal to 53. So A1 becomes plus or minus 53 divided by 243. But what is the meaning? Remember, by the way, in mathematics, when I say plus minus, I also write plus minus here. It means that if you choose plus 1, A1 should also be chosen the plus 1. If I choose minus sign, A1 should also be chosen minus 1. Sometimes in the literature, you see minus plus. It means that if you choose the positive one, you're supposed to choose the negative one. And if you choose the negative one, you're supposed to choose the positive one. Okay, so that is the convention usually you see in math books. Okay, and now I put everything back here. What is left for me is just the mere calculations. I can use my calculator or whatever. I think we don't need it here. So what happens here? Or might be we need, I know. So instead of A1, I put that, either plus or minus 53 divided by 243. Yes? And then what happens here? Plus or minus, what? What was Q? Q was 3 to the power of, yes? But do you see that the answer will always be positive? Yes? Because if I choose positive from this one, I have to choose positive from this one, and then positive multiplied by positive becomes positive. But if I choose negative from this one, the negative from this one happens if I choose the negative one from this one as well. But negative to the power of what remains negative, this is also negative, this becomes again positive. So in both cases, a 10 should be positive. Okay, so let me emphasize by that, it becomes positive. And to be honest, I don't know, this is 3 to the power 9, this is 3 to the power 5, so it becomes 3 to the power of 4, and that's 81. So the answer will be 53 multiplied by 81, whatever it is. Okay? Something like that. Don't worry about the details. Just put the numbers in the calculator, you get something. But do you understand that in both cases, which are acceptable, the answer to A10 will be positive? Yes? Okay, so that is one type of questions. Let me ask you another one. I want to wait for you to solve this one, okay? Example. The numbers so let me write it like this: m minus 1, comma 2m plus 6, comma and 4m plus 44 are consecutive terms of a GP. Determine m. Okay, so let me wait for you so that you can do it yourself. Okay, could you solve the problem? I think there is an answer in this book. What did you get for? Did you get anything for m? What is? So how should I solve the problem? These are 3 consecutive terms of a GP, and I'm supposed to find m. So how should I solve the problem? What's the starting point? No, the idea should be clear. Then I do the calculation. So if there are 3 consecutive terms of a geometric progression, what do you know about this? Because you want to determine m. Think mathematically. You need to find m. If you want to find m, you need one equation. Equation means equality. So this means that you need to set up some equality that makes sense in this context. Okay, so what can I do? Yes?
This is just a guess. If we divide 2m plus 6 by m minus 1 and get q.
Yes?
And so if we divide 4m plus 24 divided by 2m plus 6.
Yes? You get q, and these q's are equal. That's exactly the same, yeah, because I need a piece of information. So 2m, this one divided by its previous term, yes, and this one divided by its previous term, they should be the same, otherwise this is not a geometric progression in the first place. So this is what you are looking for. So you set up this equality and try to solve that. Yes? And how should I solve that? You know that this multiplied by that should be equal to this multiplied by that. Are you familiar with this? So if I have A over B equals to C over D, this happens if AD is equal to BC. Yes? Is that right? Yeah, in American say that the product of extremes is equal to the product of means. Why do you think this is a suitable name? I didn't know why this is a suitable name. I asked ChatGPT, okay? So, because A, B, C, D, these are called extremes, makes sense, and these are called means in the middle. And then you say the product of extremes is equal to the product of means. Okay, so that is actually the answer provided by ChatGPT, which seems reasonable, yes? Okay, so this one multiplied by that one, because these are coincidentally the same, so it becomes this 1 to the power of 2, and then this one plus 44, and then n minus 1, yes? Okay, what do you think I will do now? This is not a conceptual question, this is a technical question, because in mathematics, both of them are really necessary. If you understand the concept, but your technique is weak, then you mess up, okay? So what do you think I will do here? Because the standard way is just to raise it to power 2, multiply and simplify, find the quadratic equation to solve. But you don't need to torture yourself, of course. Simplification is important. I would factor 2 out from here and then raise it to power 2, yes? So if I factor 2 out, and then because of power 2 it becomes 4, but this becomes n plus 3 to power 2, yes? And then I can see that I can factor 4 out from there. So what happens? It becomes 4, n plus 11, and then n minus 1. This is something that I realize that in Sweden people don't pay attention that much. So you need to fix that in your brain as well. So for our brain, of course the answer is always the same. You can calculate and then simplify, or you can simplify then calculate. The answers definitely will be the same if you do everything correctly. But the problem is that for our brain, simplifying and continuing is much more effective, yes? So why I'm saying that? Because now this 4 is gone. So instead of working with 44, I am supposed to work with 11, which is more manageable, yes? So what I do, I raise it to power 2, it becomes ms squared plus 6n plus 9. And the right hand side, multiply, it becomes m squared, m times that, I keep it in mind, minus m. This times that is 11m, minus m, 11m is 10m, and then minus 11. And even the good point is that even the hard one is gone, so m squared is gone. So what do I get? I move 10m to the left, it becomes minus 4m. I move this to the other side, it becomes minus 20, so m becomes 5. Yes? So that was a simple question to solve. Okay, there is one more thing that we didn't have it in arithmetic progression, we have it in the geometric progression. And that is the case that when I want to add up infinitely many terms of a given arithmetic progression. Okay, for example, This is, by the way, very interesting. So here, let me just give you an arithmetic progression, 1. I multiply every time by 1/2, okay? The next term is this. I multiply by 1/2, it becomes 1/4. I multiply by 1/2 is 1/8. I multiply by 1/2 is 1/16. Then this list continues. Now my question is that if this continues forever, so I continue this multiplying with 1/2 all the time, okay? And then I start adding them up. Do you think that I will get a reasonable answer from it or not? In the case of arithmetic progression, I even didn't bother to plan the problem. Why do you think was it the case? So for example, let us have the most famous arithmetic sequence. So 1 plus 2 plus 3 plus 4 plus 5. And I ask you to up to n. This is reasonable in an arithmetic progression. But I didn't ask you about add it indefinitely. Why do you think that was the case? I even didn't bother to plan the problem. Yes.
Because
It's always infinitely big, yes? So even if I have, because you know why? Because Sn is what? Is n over 2, and then you have a1 plus an, yes? But then it becomes n over 2, a1 is a1, but an is also a1 plus n minus 1d, a1 and a1 becomes 2a1 plus n minus 1d, and then if I multiply n over 2n, this 2 and that 2 are cancelled, and then I multiply that in, something like this happens. This is Sn for an arithmetic progression. If I send n to infinity, if I make n extremely large, what will happen? Because this is a factor of n, this also becomes extremely large because this is second power. So if n is extremely large, this second power of n will dominate over this first power. So for extremely large n, this becomes very negligible, and then I will get something like that. So this limit is either plus infinity or minus infinity, depending to the sign of d. If d is positive, it becomes positive infinity. If d is negative, it becomes negative infinity. So it was not that interesting question at all, because the answer is either plus infinity or minus infinity, depending on the sign of d. Okay? But in this case, what do you think? Because let me try to develop your intuition a little bit. So every time that I progress, do you think I am making my sum bigger or smaller? No. Every time I'm adding something to it. So the first term is 1. If I keep 2 terms, it is not only 1, but 1/2 is added to it. If I keep 3 terms, I have 1 plus 1 over 2 plus 1/4. So every time that I add one number to my list, the sum becomes bigger. And how many times I am supposed to add these small contributions? Infinitely many times. So it is not clear at all what will happen at the end. Yes? Is that clear? Because I am adding a smaller and smaller numbers, I agree. Every time I am adding a smaller number to the previous sum. But still I am adding something, and I am doing it how many times? Infinitely many times. So it is not that clear at all. Either it becomes very big or it becomes small or whatever it happens. Okay? So let us try to understand that. What do you think is a reasonable way to calculate this sum? If this list terminates somewhere, I don't think you should have a problem, because we don't have the formula here, so let me write it. This is the formula Sn. Sn for the geometric progression was a1, 1 minus q to power n divided by 1 minus q. But this is when I want to add n terms. But here I want to add infinitely many terms. One way that mathematicians have defined this sum in the first place is to calculate this sum for n terms to see what happens, and then send n to infinity and then see what happens. It's a reasonable way of doing this. So what we do, instead of adding infinitely many of them, I ask myself, let us add only n of them together. Okay, but can you tell me what should I write? I write Sn formula for this list, but up to the nth term. Okay. A1, what is A1? Is 1. What is Q in this problem? 1 over 2 to the power of n, and then divided by 1 minus 1 over 2. This is not this sum, this is that sum if I continue it until the nth term. Let us simplify this. So 1 minus 1 half is 1 half, but 1 over 1 half becomes 2. So 2 goes up, it becomes 2 times 1 minus 1 half to the power of n. So this is Sn. But now I ask my question, let me call this S. S is the limit of this Sn when n becomes extremely large. Okay, so can you tell me what that limit is? 2, 1 minus 1 over 2 to the power of n goes to infinity. Yeah, you need, because the limit in high school is not discussed in details, but I think you have intuition what will happen. Yes? So what is the limit of this one? You can imagine that this is a number, I am raising it to power, but this number is less than 1. If I have a number less than 1, when I raise it to power 2, 3, 4, etc., do you think it becomes bigger or smaller? Smaller and smaller every time, yes? For example, 0.5 is a number less than 1. I raise it to power 2, it becomes a quarter. I raise it to power 3, it becomes this number. So every time I am raising this to higher powers, it becomes smaller, not bigger. So if I raise it to powers infinitely many times, nothing is left from it. So this means that the limit of this part is essentially 0, so the answer is just simply 2. Or if you don't like this, you can see it in this way. 1 over 2 to the power of n is 1 to power n, which is 1, 2 to power n. If I increase n, 2 to power n increases, the denominator increases, so the fraction decreases. But if I increase it to infinity, this becomes a very, very huge number. 1 divided by a very, very huge number, nothing is left from it. In any way, you can come up with the same answer too. So that is interesting, isn't it? So this means that this sum, if you continue it forever, it doesn't even go beyond 3, let alone infinity. So it reaches to 2. So that's something that we couldn't say. We didn't talk about that in arithmetic progression, but we need to know a little bit about this. But what is your intuition about this list? I start from 1, but every time I multiply by 2. What happens? What is your intuition without calculation? What do you think? This is also geometric progression. So I start multiplying it by 2 every time, and then I add them up. What do you think will happen? Yes? The sum will be infinity. Why? Because instead of having 1 over 2, you have 2 to power n. Yes? And then if n is big, it becomes also very big. So that becomes infinity. So we can say that Sn, if absolute value of Q is less than 1, then S, usually people call it S infinity, is the first term divided by 1 minus Q. And if absolute value of Q is greater than or equal to 1, S infinity becomes infinity, yes? So this is why it is good sometimes. This formula is not in the book, but this is the only one given in the book. But if you face a problem with infinitely many terms, you understand it yourself, that if Q is less than 1, that part becomes 0 when n becomes extremely large. Yes? Is that clear? Yes.
S infinity,
This is the notation we use.
yeah, but if we use 1 as Q,
No, 1 doesn't work.
but you have rows.
Oh yes, it becomes infinity, because let us say that first number is 1 and Q is also 1. The second number is 1, the third number is 1, the fourth number is 1. I am adding 1 to itself infinitely many times, so again it becomes infinity. So these are just sloppy notations, don't stick to that, but I'm just to refer. Okay, so that is something that we have, and the lesson is finished. Okay, thank you very much. Just wait a little bit.